lecture, we started talking about dimensionality reduction. Remember, you're trying to take your high-dimensional data with a large set of attributes and somehow represent it with a smaller number of attributes. We started talking about this technique called PCA, Principal Components Analysis. So the basic idea behind that technique, again, remember, we suppose that we have our low-dimensional data embedded in a high-dimensional space. So we have a three-dimensional space here, this cube, but all the points lie on a sheet, on a two-dimensional sheet, a hyperplane within that space. So what we'd like to do is we'd like to discover that hyperplane and represent our data points in the coordinates in that hyperplane. So, and what PCA does is it looks for dimensions of greatest variance. So dimensions along which your data is spread out as much as possible. So PC1 and PC2 are both vectors that are inside that hyperplane. They go along that hyperplane. And along those vectors, the data is spread out as much as it can be. Right? So PC1 is the direction of the greatest variance, and PC2 is the direction of the greatest variance that is perpendicular to PC1. Right. And together they span this hyperplane. And then we have PC3, which points perpendicularly to that hyperplane. And the variance of data around PC3 is very small, right? Because all the data pretty much lies on that sheet. So in that case, what we would do is we would pick PC1 and PC2 as our new coordinate vectors, and we would re-represent all of the points in terms of these new coordinates. So this yellow point, previously it was a point in three-dimensional space, had three coordinates, x1, x2, and x3. Now it's only going to have two coordinates in terms of the principal component 1 and principal component 2. So what we're going to do is we're going to take that point and we're going to project it to PC1. So that's the projection to PC1. It's going to get a slightly negative value for the first new coordinate, and it's going to have a highly negative value for the second new coordinate. So we went from points in 3D to points in 2D. That's what we want to do at a high level.